Hey y'all. Um, we're back. 8 months later. So I apologize for the huge gap in these videos. Um, Life stuff got in the way. And then the other thing is I've been trying to wrap my head around how we'd actually accomplish the goal. So uh, when we left off, we were talking about doing uh, our cube intake. Cubes, if you recall, again, it's been 8 months. The goal for this robot is a cube only robot that would ideally be able to score in all three positions, low, medium, and high. Be able to pick up cubes from the floor, and if possible, maybe a cube drop to it from the human player station. So I was kind of racking my head around how to go about designing one of those things, and for those of you new to CAD, um, from scratch designs are awfully difficult for, I mean, even intermediate level CAD folks. Like I thought about it a lot over the last couple weeks, and I'm like, I don't want to design this thing from scratch. And one thing that, again, I've only been doing this a year, or doing mentoring a year, and one of the things that a lot of the FRC folks who have done CAD a lot is, what they've told me or recommendations is borrow from the best and create what you have to. Uh, so far with this robot, all we've been really doing is dragging and dropping prefab components, and we've gotten pretty far. I mean, it was 4 videos and we've got a rolling chassis, right? So, in the interest of trying to get this thing done here in the next 2 weeks. 2 weeks. We're 2 weeks from the 2024 game kickoff. So my goal is to get this thing done here in the next 2 weeks. So thankfully, I got a lot of time over Christmas, so I can start banging away some videos. So, in the interest of trying to get it done, we're going to stick with the steal from the best. And one thing that was prevalent in last year's game, Charged Up, was there was definitely a very good intake method that a lot of people used. And for those of you who aren't aware, there's a system called the Everybot, and what happens is Team 118, the Robonauts, what they do every year is they develop a robot design that is fairly low cost, low. You don't need a whole lot of tooling, specialized tooling, to be able to build this robot. So they design a robot and it's unveiled. I'm not sure if it's at kickoff or a week or two after. I don't know that. Again, I've only been doing this a year, but it's designed to be a halfway decent robot that doesn't require a whole lot of resources in order to be able to build or program or operate. And so what they did last year, the Everybot robot for 23, for Charged Up, it had an intake that a lot of people, a lot of teams cloned and copied. So this is what it is. So basically, it's just some polycarb side panels. And I got it CAD. We'll pull it up in a minute. But polycarb side panels with just some rollers and some gearing. And what happens is this this gap in here. If you can see my cursor there, that gap is designed for cubes. And then this smaller gap here is designed for cones. And the way they've got it geared up is so that all all the rollers are rotating the correct way for intake and part scoring. So that's what all this gearing is meant for. So what we're going to do is we're going to take this Everybot intake, and we're just going to modify it for our robot. And the two modifications we really need to do is, one, we need to get rid of the cone part, because we don't need that cone. We're not scoring cones. We don't care about cones. We've sacrificed that, so we can shorten this up a little bit. And then the other thing we need to do is, this thing is actually really wide. I don't know. We'll see when we get into the CAD, but it's really wide. And I think, I can't remember how wide we made our robot, but it's not the widest. So thankfully, whoops, I dragged that off too soon. West Coast Products, again, we get all the CAD. So I've already downloaded it to my computer and uploaded it into Fusion360, and it's sitting right there. So what we're going to do, let's just go ahead and open this up. You can see I've got the old rolling chassis in there, and this is how it looks coming straight from West Coast Products. It's going to be a little bit wider than what we need. So let's go ahead and measure that. So we'll see from that edge to that edge. It's 16 inches. So let's go back to our robot and see what it looks like. Now, the other thing we can do here is, even though we're going to make some edits to this, we're going to start pulling some stuff off of it. I'm going to go ahead and drop it into our intake brainstorming, so that whenever I make a change to the intake file, it will update in our full assembly. So the first thing, actually, let's just leave it there for now. So we'll just hit OK. Just leave it there for now. But we've got to get this thing in the right orientation. I hate how this is all in the wrong orientation. So what we're going to do is, I'm going to do a Control A. That won't work. So we're going to just go down and pick everything in the tree. Scroll down. So I clicked the first item up there, and that's how I got this polycard panel. And I'm going to shift click down, and I've now selected everything. So I want to move that and get it all into the right orientation. And the only thing we need to do that is rotate it 180 degrees. There. All right. So what I'm going to do is, I'm going to save this. And then go back in here, and you'll see that my component is out of date. That little exclamation point sign there, what that means is, hey, somebody, me, made an edit to a component that this drawing is referencing. So what we're going to do is get the latest version. Remember, all I did was flip it around. It's not showing that rotate. It's not showing in this file. So what I have to do now is, I can either right click and get the latest version, or it's also reflected up here in the main toolbar. So I'll do that. You can see now I've got my rotation. I'm not going to worry about the positioning just yet. I'm not going to worry about the positioning, I should say, in the intake file itself. I'm going to worry about the positioning over here. So let's go over to the top. And then the nice thing too, by doing that, is I can just click once and get the whole assembly. And I hit M to move it. And right there, it looks about centered, maybe a little bit more. Again, I'm not overly concerned with how centered it is at the moment. We will fix that in a little bit. And what I'm doing to gauge how centered I am is I'm just looking at these mounting holes for the sword modules. So this is like 3.5 mounting holes, and this is right on 3. That's too much. Again, too much. Probably gonna spend way too much time on this because I'm an engineer. That's close enough for what we want. Now, we also want to look at it vertically to try and get it to the right spot. That's pretty close, because what we're going to do eventually is there's going to be a little bit of give to that intake, the way we got it, what we're going to do with it, so that it will be able to go up and over the cube. So it doesn't have to be, you want a little bit of give. Now the other thing we have to do is bring it back a little bit, because we don't need to be that far out past the robot. So let's double check. That actually looks pretty good in terms of width. Still got a little bit of room on either side of the robot. Heck, I mean, if we wanted to, we could even go even wider. But I think for now, we'll keep it the way it is. Again, trying to get this thing done in the next couple of weeks. So all in all, that positioning looks pretty darn good. And we'll just hit OK so we can get rid of the part selection. And if you look, there's a pretty good amount of what we call interference between the cube and the rollers, both from mainly from a side view. Like if I turn these polycarb panels off, which I'm not going to, because then I'd have to bury myself in the part tree. You can see there's a pretty healthy amount of interference, which is a good thing in this case. Now, the way this intake works is these rollers, you got a Neo or a Neo 550, whatever, back here that is driving this belt, and that is driving this shaft. And then it's just snaking through the in between the polycarb rails, so that this rod is always rotating the opposite of this rod. So to do that, there's some gearing in there. You can see if you look at this, this belt is really long, and it comes up to this front roller. Okay, now what happens is, that means the back roller, that one right here, and this one rotate the same direction. But for this one, there needs to be a change in direction. And to do that, they do some gearing. And that gearing is over here. And actually, I will turn this plate off. So you can see that gearing is right here. So what happens is, remember, there's our motor. That's driving the rear shaft, which is also driving the front shaft because of that long belt on the other side. And that comes through here. But if you look, there's a belt coming up here. That means this shaft is rotating the same direction as these two, the rear and the front. But if you look, there's this gear pack here. that is what changes the direction. And that's what we need to end up saving. We need to figure out a way to get um, the motors. If we're going to eliminate this front package here, which I really, really would like to do, we have to figure out a way to get this shaft and this shaft rotating in opposite directions. Okay, in the interest of trying to get this thing done, I'm going to table the discussion on removing the front roller. I mean, there are ways around it to get the counter rotation, but for now, we might come back to it. But now, what we have to do is try and eyeball and figure out, hypothesize some ways that we get from the front of the robot and maybe into an intermediate position in the middle so that we can protect our very, very important cube as we're traversing across the field, and then be able to eject it out this way. So all we're gonna do, you can see I brought in the scoring area, and all we're gonna do now is we've got this in roughly in position fore aft and up down, but we can play around with where about we want to position like a pivot. Like if we wanted to come over just a simple one axis pivot, there's not a whole lot of weight out here, so it doesn't have to be super robust and doesn't have to be geared down really, really strongly. So it doesn't have to be, so we could probably get away with just a simple single pivot. So that's what we're going to try and do. So what I'm going to do is collapse those. So there's our intake. And all I'm going to do is start messing around with a hinge position. So now the thing we got to keep in mind too is when we hinge it, we got to also kind of think of at what angle do we want to launch this at, because they're like, obviously the ideal angle is about 45 degrees. It's the most forgiving in terms of speed accuracy coming out of the intake. So we're going to try and think about seeing if we can get this plane that's made, or this line, to 45 degrees as much as we can. So thankfully Fusion just picked a random rivet hole, because eventually what'll happen is those will get riveted to some 1x2, and let's just see what happens. So that's about as far as we can get it, which doesn't look like it's going to be enough. It's nice in that it's enclosed fully in the robot, and you can see here, but it doesn't leave a whole lot of room for anything. So let's see if we can pick a different pivot. We're going to cancel that, and then I'm going to just try and move it again. So this time, let's go to the right, and I'm going to change my anchor point this time, and to do that, over here it's set pivot. So I'm going to click on that set pivot, and now you can see it doesn't really matter what this angle's at. It's just like starting. It doesn't really matter. So, but we're going to use that pivot, that rivet hole, as our axis, and see what happens there. Let me zoom up a little bit. Getting closer. And the other nice thing is if we can contain this whole thing in the robot, this could almost be our starting position. which would be really nice. It'd allow us to preload a cube, and go at launching. That might be too much. Let's see. Are we hitting anything? Oh yeah, we're crashing right into our swerve modules. Okay, that's bad. All right, so it's looking like we're gonna have to start making our pivot somewhere 2 or 3 inches above this point here, which kind of stinks. We could also go a little bit rearward, but again, what that would do, and by rearward I mean following this line up to somewhere right around here. Oops, not sure what happened there. We could do that. We could follow it up a line like this. The problem with that, though, again, becomes starting position of the robot. The further out and towards the rear of the robot we go, the further out our intake will extend from the frame of the robot at start, and we don't. It would be nice to have a start position where we can just and pop a cube up into the launch and not have to position the cube or position the arm in a position. Now, another option we could do, no, we can't, never mind. So now we have to figure out, okay, how far up do we go? So we'll come back to that in a second. Okay, after some careful consideration, I've decided to not relocate the pivot point, and I'll walk you through why. So let's go ahead and put that back using the last pivot point we used, which was this top rivet hole. We'll do that. And then we're going to rotate it all the way back around again. So we can keep going. And so let's even go even further. Right about there. All right. We crashed pretty hard through all of our swerve modules, right? That's a bad idea. But if you remember, we had said we were going to try and eliminate this as best we can, that front intake there. So problem one is we have to figure out how to get rid of that front intake, or that front axle. And then the other one is, the other problem was, how do we get this axle to rotate in the opposite direction of this axle? Well, it occurred to me, we've got another motor mount back there. So we could literally just, if we wanted to, we can throw another motor back there and go straight to this axle without any problems, and just have this motor and this motor run at the same speed, just different directions. So that solves that problem. And then if we go through and we say, hey, follow through on our commitment to eliminate this whole front axle and clean off all this polycarb that we said we weren't going to use and didn't need, that could solve our crashing problem. And then if I look at it from the right, it's not exactly 45 degrees. I don't know if this is going to give us an angle in a plane. Doesn't give us an angle. Let's see what that does for us. Nope. I mean, we could do the trig realistically if we wanted to, but I mean, looking at it, it's 30-ish degrees down. I mean, so the cube will launch out at roughly 30 degrees, and that's we could even possibly get it further depending on how crazy we go with cleaning this out. I mean, we could almost get it to sandwich down and sneak behind um, this 45-degree frame of the swerve module. So let's commit to that. And that's the one thing with CAD and the robot brainstorming ideas. Once you get to a what your team feels as a solid idea, you get more people moving towards a certain idea. Just cut bait, cut and run, commit to that idea, because with the way FRC robots go and the timing, the such short time frame it takes to brainstorm and CAD and build and test, there's not enough time to just iterate and iterate and iterate on possibilities. You have to commit to one and just go. So that's what we're going to do. We're going to commit to this idea and go for it. And if we have to think about other ways to do it, we're going to do it. So next video will be clearing this out. We'll probably dedicate most of the time to updating this Everybot intake.